I'm Amy Mackey. I'm a watershed coordinator with the Ohio University Voinovich School. So I do a lot of work in Raccoon Creek, but other watersheds in primarily southeast Ohio. We do sampling, project maintenance, grant writing, things like that.
To really know what the water quality is like in a section of stream, researchers collect both chemical and biological data in each stream section. Fish and bugs can't just pack their bags and leave if the chemistry changes, so we use the fish and macroinvertebrate communities as long-term indicators of biological health.
So this is the method we're going to use today. This is a long-line electrofishing unit. There are other methods of sampling fish. There's seine nets that are good for like using in riffles, but with a seine you can't get fish out from under rocks or out from under an undercut bank or under a big tree. You can use rod and reel, like angling, fishing. That's great for catching sport fish, the bigger fish, but you're not going to catch little tiny minnows and darters. There's trap nets, which a lot of the agencies use in big rivers and lakes, but those things don't work in stream situations like this where you want to know all of the species that are present. So the electrofishing methods are really the best for these stream sampling environments. There's a backpack electrofishing unit, the long line, and a boat. They all have very similar components. Today we'll use the long line. Long line's used anywhere where you can safely wade, wearing waders. The backpack is for a lot smaller streams, doesn't produce as much electricity, and the boat is larger waters, lakes, big rivers where you cannot get in and walk and wade. So a few parts of this system we're going to use today. We have a generator. This is not the same generator you would use to power like your refrigerator at home during a power outage. This is made specifically for electrofishing. This is a pulsed DC current. So this current is on and off, on and off, on and off really, really fast. So you can't just use this to plug in your refrigerator. And one thing to know is that average Joe off the street is not allowed to use this equipment. This is for research and education only. It is a very effective method. If everybody was out doing this, people could over-collect species. So, a couple components of this system. We have the generator that produces the electricity, and then we have the line. This is where it gets its name, the long line. It is a waterproof line. It's hooked to the generator. At the end here is our net, which is the anode, the positive end, and what Kelly has in her hand is the cathode, which is the negative. Both of these have to be in the water in order for the electrical current to be produced. The way this works is this electricity causes a fish's muscles to contract and relax really fast, and that forces them to swim right towards where the electricity is coming from, which is our net. When they get close enough to it, they actually pass out, float to the surface. And from there, we'll scoop them up and put them in our live well. This is a live well. It has a bunch of holes drilled in it so that water is constantly circulating through the live well, helping to keep the fish alive. If you just put fish in a bucket, how do fish breathe? They breathe oxygen in the water through their gills. They utilize all the oxygen in a bucket of water really quickly. So the live well helps keep the fish alive and happy until we're done with our sampling reach and we can process the fish. All right, so electricity and water. Not always the best combination. So there's quite a few safety things that we have to make sure are in place before we use electrofishing equipment. You can see that Kelly and I both are wearing rubber gloves and waders. These are to protect us from the electrical current that's in the water. Rubber does not conduct electricity. One thing to remember, even though you're wearing gloves and waders, that doesn't make you invincible. If you go out there in the water and you go over your waders, you're going to get shocked. If a fish floats by and you reach down to grab it and you go over your gloves, you're going to get shocked. So you still have to watch the water level even though you're wearing waders and gloves. Watch out for each other. If you're in deep water, don't put your elbows down into the water. Another thing, these net poles are made out of fiberglass. Fiberglass does not conduct electricity. This net pole here has a safety switch on it. This switch right here is designed to protect everybody in the water, but primarily the person who is shocking. As I'm shocking, I will have this switch depressed. When this switch is down, the electricity can go out into the water. If this switch is up, that cuts the electricity off. So when I'm shocking through the water, if I trip and fall and let go of this net, that cuts the electricity, in theory. But these switches can fail. This is one of the most common things that fail in these systems. So we're always watching out, making sure these are still working. Also, remember I said you have to have the anode and cathode in the water. So another good way to sort of cut the electricity quickly is pick your net up out of the water. But the only surefire way to cut all of the electricity is right here. This on-off switch on the generator here. So if the generator is not running, there's no electricity being produced, there's no electricity going into the water. So that is our biggest safety feature right there, is the power switch on the generator. We always make sure the whole crew knows where that switch is and how to quickly turn the generator off. It's always a good idea to have a safety person on the bank ready to turn that generator off if there is an issue. So that's a big one everybody needs to know. Communication on a fish crew is very important. The person shocking is very focused on getting fish. Very focused on sampling all of the habitat, not as focused on what the people behind them are doing. You can't see them, the generator is loud, you can't hear them. It's important for the whole crew to communicate if there's logs, if there's big rocks, if something's really slippery, if there's a deep hole, if there's a hornet's nest hanging in a tree. Yes, all these things happen when you're out on a fish crew. So it's important for everybody to watch out for everyone. If there's a hazard, hand off the switch, net out of the water while everyone gets around it. If there's a really big tree, really deep hole, turn your generator off till everybody gets around it. We have gloves and waders on to protect us. You guys do not have those things on, so just make sure you stay back far enough away from the water that if the little folks would happen to trip and fall, they're not going to end up in the water. Just want to reduce any risk possible.
When sampling a reach with a long line, you always work from downstream to upstream, typically a 200-meter reach. Ideally, there are 4 people on the fish sampling crew. One person runs the shocking net and sets the pace of the crew, everyone else stays downstream of the netter. The netter needs to keep the shocking net in the water as much as possible because if the net, which is the anode, is out of the water, there's no electrical current in the water and fish will get by. Another person is the assist netter. This person stays right next to the netter to scoop up the fish that are stunned by the electrical current and transfer them to the live well. One person pulls the live well. The live well tender stays close enough behind the assist netter so they can reach the live well, but far enough away from the electrical current so the fish in the live well aren't getting continually shocked. Any additional people on the crew help to tend the line. The line is 100 meters long and will get stuck on rocks, logs, debris in the stream, anything that's there. If the line is stuck on something deep down in the water, the line tender will make sure everyone is aware, the netter will take their hand off the safety switch and the net out of the water. The reason we use electricity to sample fish is because it's the most effective way to collect fish from all the habitats present in an aquatic system. Most fish don't hang out for very long in the open water. They're usually hiding along the edges of the stream or under something on the stream bottom. The electricity can pull fish out from under rocks, out of deep pools, out of undercut banks, roots, and aquatic vegetation, places you can't access with nets or rod and reel. If we're sampling in a riffle or fast-flowing water, the assist netter will rest their net on the bottom of the stream, and the netter will move the anode from upstream down into the assist net, dragging along the stream bed to dislodge any small fish like darters that might be stuck under the rocks. When sampling a deep pool, the crew needs to move slowly and cautiously and pay attention to the water level. The netter will pull the anode from the bottom of the pool quickly up towards the top of the water to help bring fish to the surface where they can be netted. Sometimes fish that are hiding in undercut banks, thick vegetation, or under big rocks will get stunned but get stuck in their hiding places instead of swimming to the anode. If the netter quickly pulls the anode towards them, it will create enough water movement to pull the stunned fish to the surface where they can be netted and placed into the live well. When we finish sampling the reach, we need to process fish. This is when all the fish in the live well are sorted out by species, then each species is counted. At larger sites with more than a 20 square mile drainage, each species is also weighed. The total count and weight of each species will be recorded on your data sheet. Filling out your data sheet accurately and completely is extremely important. Make sure all of your site information is correct. Be sure to write the date and time of sampling, who was on the sampling crew, the length of your reach, and any other pertinent information. If you voucher any fish, or if there are any sort of deformities, erosions, lesions, tumors, or parasites to note, be sure to record that information as well. When processing is complete, the fish are released back into the stream at the sample site. Smallmouth bass are a popular sport fish and a member of the Centrarchidae family. This family includes the sunfish and black bass. Unlike the largemouth bass that prefers lakes, ponds, and sluggish streams, the smallmouth prefers faster flowing, well-oxygenated waters of streams and rivers. Smallmouth are an olive green color with mottling and vertical bars. The mouth of the smallmouth is large, but only extends to about the center of the eye, where the largemouth bass has a mouth that extends to the back of the eye or beyond. Smallmouth are predatory and eat crayfish, aquatic and terrestrial insects, small fish, and whatever else they can catch. The rainbow darter is a member of the Percidae family. This family includes yellow perch, walleye, and sauger, which are all popular sport fish. Rainbow darters are a small fish, reaching only 2 to 3 inches in length, and are sensitive to pollution. They're only found in relatively clean, fast-flowing water with plenty of rocks to hide under. They eat insects and stay on the bottom of the stream in riffles. Males are very colorful, with blue and orange stripes and spots, with females being a much more drab brown.
Talk is about minnows. You guys know what a minnow is,
Oh,
right?
yeah.
How big are minnows?
Maybe about an inch.
Are they? Like,
This is
this
a minnow.
is a minnow. Carp are in the minnow family. Minnows are just a family of fish. This one here is a golden red horse. This is a variety of sucker. You can see by the placement of their mouth, this is a bottom dweller. They live on the bottom of the streams and they use their downturned mouth to find macroinvertebrates in the bottom of the stream channel. This one's a rock bass in the same family as the largemouth bass and all of your sunfish. This one has a mottled sort of camouflage coloration. In the sun they'll have a red eye, really large mouth. They'll eat macroinvertebrates and other fish. They do typically hang out in rocks. The fish that looks very similar to them is the warmouth sunfish, but the warmouth will only have 2 to 3 anal fin spines, where the rock bass has 5.
The long-nosed gar is a primitive species of fish in the Lepidostidae family. A large fish reaching up to 6 feet in length with an extremely long, narrow, tooth-filled snout. The gar is a predator, catching smaller fish as they swim past. Gar have diamond-shaped ganoid scales that lock together like a suit of armor to protect them from predators. They also have a specialized swim bladder that allows them to breathe by gulping air at the surface. This feature allows them to survive in waters with low dissolved oxygen.